If you look at this problem, students, it's told alpha and beta belongs to the set of real numbers and z is a complex number. Okay, and all the complex number what you have to see satisfying this equation has distinct roots on real part of z is equal to 1. So if I take z is equal to x plus iy, the real part of this complex number is 1 as told in the problem. So I can take this x is equal to 1, correct or not? This implies x is equal to 1. So I can say here this complex number looks like this, 1 plus iy, correct? So, and we know that all these, see now this is nothing but z square plus alpha z plus beta, correct or not? Is a quadratic equation in z. So one value of z is 1 plus iy, correct? One root. Therefore other root will be, it's a quadratic equation, right? Other root will be the conjugate of this. Z is equal to 1 minus iy, correct? We can call this as m, we can call this as n, say. Okay, we'll call this as m and we'll call this as n. Now z square plus alpha z plus beta, that is equal to 0. Sum of roots, that is equal to minus alpha divided by 1, that is equal to minus alpha. Product of roots, that is equal to beta by 1, that is equal to beta. Question is asking beta belongs to dash, right? Which means answer is here only. So I can write 1 plus iy into 1 minus iy, that is equal to beta. So I can write 1 minus I square y square, that is equal to beta. So 1 plus y square should be equal to beta. If 1 plus y square should be equal to beta, this implies that beta belongs to, when y can take any real number, y can be any real number, right here. So y can be 0, then beta will be equal to 1, 1 can be the answer, and all the other positive numbers, because y square is always positive for any value of y. So what is the answer that we get? A closed interval 1 to infinity is the answer to the question.